Okay, so let's talk about Splunk down here at the bottom, boss of the SOC. And Splunk is the #1 SIEM tool, or at least it was a couple of years ago. It's possible that IBM's has another product that's a competitor with it. But anyway, Splunk is still very important, and the great thing about it is that you can use it for free on any amount of archived data, which makes it extremely handy for teaching. All right, so all you need is a web browser. You can connect to my server. I made 2 of them, Splunk and Splunk 2, and you have to log in with student 1 with a password of student 1, which is not very secure, but it's enough to stop automated attacks. I was getting some automated attacks against my server, and this seems to stop it. By the way, there was a warning there about the time. It turns out by default, Splunk will only use data that is less than 5 years old, and this data is now more than 5 years old, and the easiest solution I found was to change the date on my server. So my server thinks it is a couple of years ago. That seemed to work. That's a sleazy workaround, but it gets you there. And the only thing we're going to use is the main app in Splunk, Search. Splunk is Google for log data. That's the point of it. The point of Splunk is you take all the data from all your devices, your domain controller, your email server, your firewalls, everything, and you forward all that data to a central database, and Splunk helps you search that database. So you can find attacks, you can query machines, you can find all the log data in one place. By default, it only searches data from the last 24 hours, but as you can see, most of the data on this server is 7 years old, and that's the data we want to search. So we want to change this search to all time. And if you just put a star up here, you'll find everything. Now the speed of a search in Splunk depends on how many results there are. So there's 1 million events 7 years ago. If I search for star, I'm going to get 1 million hits. That's annoying. So to make it faster, I'm going to change the event sampling to 1 in 1,000. Now I can search, and I'll get 1/1000th of the data. And when you search, you have log entries here and some data about them there. But let me go back and just talk about what kind of data we have. I'm going to go to the plain search page again and just work with the summary of data we have here. So right here it tells me 1.1 million events going from 7 years ago to 4 years ago. You can click Data Summary and see what kind of data Splunk gives you. First, it gives it to you by host's name, which is determined by the company, but I'd rather go to source types to talk about what types of data are out there. Here you see some Windows event log data, which is just what you think it is. This is the Microsoft event log created with the Windows operating system. Then the registry that we were just talking about with using Autopsy to examine the registry, Autopsy and FTK. Here's Sysmon. Sysmon is a fantastic product from Microsoft you can add to your server that will create extra log entries that are much easier to interpret. There's only about 12 types of events, and they are nice, easy to interpret, like opening a file, launching a process, creating a registry key. It gives you nice, simple events with all the information you need to understand what they're doing. Here's FortiGate events. FGT, FortiGate is a firewall, and these are the firewall logs. And if you go to this A is some kind of extra extraneous junk. Here's Microsoft IIS web server logs. Here's a Nessus scan, some kind of log entries about that. And then there's stream data. Stream data is from Splunk sniffing the network like Wireshark would, but it doesn't save entire packets. It saves a summary of the data flows in these various protocols. And then there's Suricata, which is an intrusion detection system, an open source one. So Suricata data will include detected malicious data on the network. And then syslog is Linux syslog, system log, the Linux equivalent of Microsoft event logs. So those are the types of data that exist. Now, let me move my instructions over to the side so I can refer to them while demonstrating stuff. So the first thing we're going to do is look at the HTTP data. So we do that by, you can do it actually from here, from the data summary, you go to source type and go down to stream HTTP. Should be here. There it is. If you click that, it will add it. Source type equals stream HTTP. Now you can learn to type in these queries, name equals value, but you don't even have to if you let that do it for you. Now it found nothing because it's set to last 24 hours. I need to go to all time. And now I'm going to change my event sampling to 1 in 100 to make it faster. And we'll find 237 events. And here they are. So these events, I can make the font bigger. There. So here you see log entries one by one. This is all the information from one log. Here's a web request that got a 304 not modified. Down here is the request. Down here is the next request. So you can examine these log entries one by one, reading through them here. And if you do that, it only works if you have somehow isolated yourself down to a reasonable number of events, and I haven't. I have more than 100. So what we're going to do is add the name of the web server. Now these guys made a scenario where they set up a corporate network with a series of servers on Amazon, and then they attacked it with various tools, and they gathered all the evidence from it, and they used this domain name, I'm really not Batman.com. That's just the domain name of this company. So if I add that, I'm going to get web requests to my company web server because no other web requests would contain that name. Now you can use Splunk like Google, where you just put in a word and it will just look for that word anywhere in the events. If you give it name equals value, it'll look for that value in that specific named field. But if you just put a word here, it'll accept that word anywhere in the event. And so now I have 238 events going to the web server. And if I look down here, this is a post to a Joomla server. And notice right here, this is what I was looking for, Acunetics product. This is a vulnerability scanner. Acunetics is a commercial vulnerability scanner, one of the common ones. And what happened is the bad guys had a copy, perhaps a pirate copy of that scanner, and they scanned the network. And they appear to be pretty stupid attackers because they didn't even take these off. Commercial vulnerability scanners add marks to every request so that when you see it in your logs, you will know this came from a vulnerability scanner, which hopefully is your own company security team scanning your server. And they want to make it easy to spot. So the bad guys didn't take that out. So from this one request here, showing the Acunetics, I can now answer several of the flag questions. If you go down here, you find that third-party scanner. And now you want to know the name of the scanner. Well, you can see it there. It was Acunetics. The attacker's IP is the source of this traffic, and the web server IP is the destination of this traffic. And so I'm going to make a notepad file over here, or in my, not notepad, but anyway, my text editor, because I want to keep. So this is a malicious traffic. Here's the first flag, Acunetics. I'll just copy that in my file. And the attacker IPv and web server IP. Okay, the attacker's IP is the source of this traffic, which is going to be down here, source IP, starting with 40. So that's the attacker's IP address. And the destination IP is here, 192.168. That's my web server's IP address. And all those are going to help me later. So that's the first several flags. Now, I'd like to find a defacement file name, and this is where you begin to really see how powerful Splunk is. Now, we now know that the web server's IP address is 192.168.250.70. And I'm going to copy that. Okay, now, suppose it is a destination IP because requests are coming in to that server. Now, I want to have an HTTP request where that is a source server. So I'm going to go up here, and I'm going to put that in as a source IP address. So I can go down here and look for source IPs. You can choose one here, and there is source IP. If I click that, there were two source IPs, one with 40, one beginning with 23. I'll just click the 40 one, and that will add it to the query. And now I can replace the IP address in here with the IP address of my web server. And when I run this one, I'm going to find 0 events. Now this is what you would expect. In a proper network hygiene, your web server should be a server, and you should not allow it to be a client. You don't want somebody on your server opening up Microsoft Edge and surfing to a website and downloading a file. You're not supposed to do that for several good reasons. One reason is they might download a virus and get your server infected. If you need to put a file on the server, you should download it on a workstation, scan it for antivirus, and move it over with a file share or something. You shouldn't be downloading it directly on the server. Another more important issue is bad guys hack into servers. They send up some kind of malware, they trick the system into running that malware, and then they try to phone home to a command and control server, making a connection to the internet from the infected device. And you don't want to allow that. So your web server should be receiving requests from the outside and responding to them. It should never be initiating web requests from the inside. And that's what this would do, a web request coming from the inside. However, this is traffic going backwards through the network. However, that did happen. The reason I'm not seeing it, there are two reasons. One is I have sampling. So if I turn off the sampling, I'll see how many there really are. There's still 0. The other problem is, remember, this is a request made from the web server. It is not going to have my web server's domain name in it. It's going to be going somewhere else, like Google or Yahoo or something. So I need to take this "I'm really not Batman" out of there. Now I'm looking for HTTP traffic originating from the web server. That should never happen, but that did happen a few times. Out of all those 1 million events, it happened 8 times that web requests went the wrong direction through the network. And that's why when I saw this, I said, this is wonderful of Splunk. I just searched through 7 years and 1 million events and rapidly found suspicious events. This is why Splunk is great. So now using this, now there's down to just 8 packets. You can just look at them one by one. And right here I see it, downloading a malicious file. Poison Ivy is coming for you, batman.jpg. What the bad guys did was infect the web server, get code execution on it, then download malware and deface the web page with an image. So you get the file name of the defacement file name, and you can get the hosting server which was used to host that file, which has this strange domain name, which not only sounds funny, prankglassine-jumpingcrab.com, it's also on port 1337 instead of on port 80 or 443, which is a common hacker term to use. So this is a suspicious domain name and a suspicious port number. And that's the first bit of things you can do on Splunk. And as you go ahead, the next thing you can do is you can find a brute force attack. There's a brute force attack in here where they tried hundreds and hundreds of passwords until they got in. And you can find all those events and get a nice table of them showing the attack. Then you can find the executable file they uploaded to the server after they found the password. You can even read the script that did it. You can find how long it took them to hack in. And then you can find ransomware. There's a ransomware attack here. You can find the USB stick that was plugged in that had the malware. You can find it running the ransomware. You can track it encrypting the files on the network and then opening the ransom note. You can reconstruct all of that by just going through these Splunk searches, and it's a great thing to do. So that's what I wanted to show you.